Hi everybody, in this video I'm going to show you an example of a video that would receive full credit for a video project submission based on the criteria that you guys will be evaluated on when you submit your video projects. So the topic that I'm going to cover is the Pythagorean theorem, which is actually an 8th grade topic, so it's not something you would introduce in elementary school, but it's still a good example of what I'm looking for when I ask you guys to explain the why of whatever your assigned topic is. So I'll go ahead and show you that video, and then I'll come back to this slide and explain how my video met the criteria for this rubric.
The Pythagorean theorem is a statement that says that the side lengths of a right triangle will always have this relationship between them. So A and B in this case represent the lengths of the legs of the right triangle, and C represents the length of the hypotenuse of the right triangle. And if you square the lengths A and B and then add those two squared distances together, that will equal the squared distance of the hypotenuse. And this is a really useful relationship to have whenever you're looking for the missing side length of a triangle. So let's say, for example, that I was building a birdhouse, and I've built the bottom part of my birdhouse, and the distance across the top of the wall of my birdhouse is 16 inches. And I have a popsicle stick that is 6 inches long that I'm going to use to support the roof of my birdhouse. So the very tip of the roof is going to be 6 inches above the wall of my birdhouse. So what that means is that this distance right here is going to be 8 inches because it's half of 16. And let's say that I wanted to figure out how long of a stick or a board I would need to create this diagonal part of my birdhouse roof. Well, because this shape right here is a right triangle with a right angle here, I can use the Pythagorean theorem. And I can say, based on the Pythagorean theorem, I know that 6 squared plus 8 squared has to equal this distance squared. So I'm going to call that distance C because that's the same variable that is in the Pythagorean theorem formula. And then I'm going to use this information to help me figure out what C is. So 6 squared is 36, 8 squared is 64, and if I add those together, that should equal C squared. So that means 36 plus 64 is 100. And so that distance of this side of my triangle or the roof of my birdhouse, if I take that distance and square it, it would equal 100. So to find out what the distance is, I could either square root both sides, which tells me that C equals 10, or I could just know that 10 squared equals 100. And in either case, that tells me that this distance right here is going to be 10 inches. Now, if I was making a birdhouse, I may want to actually make it 11 inches so that I have a little bit of an overhang so that when it rains, it doesn't drip down the wall. But that's how I could use the Pythagorean theorem to help me build this birdhouse. So why does the Pythagorean theorem work? Like, where does this formula come from? And why is it always true? Well, if I take any right triangle with the side lengths A, B, and C, I could make 4 copies of that triangle and arrange them in a square shape like this. So here's one of my triangles right here. And then I have another triangle here, and another triangle here, and another triangle here. And all together, these make a big square. And if I wanted to find the area of the square, I could find the area of all the little pieces inside the square. So the area of this triangle would be 1/2 times the base times the height, which would be A and B in this case. Then the area of this triangle would be the same, so I could just add that, 1/2 times A times B, whatever A and B are. And same thing with the other 2 triangles. So that would give me the area of all of this space here. And then the area of this big center square, because the side lengths are C, the area of that would be c squared. And I could simplify this because if I have half of a times b plus another half of a times b plus another half of a times b plus another half of a times b, this could be simplified to just be 2 times ab, because a half plus a half is a whole, and then plus another half is 1.5, plus another half would be 2. And so I would have 2 of whatever a times b is. And then I would also still have the area of this inside square, which would be c squared. So the area of this big square would be 2 times whatever a is times whatever b is plus c squared. Now I could also find the area of a square that has the same dimensions, but find it in a different way. So in this case, again, we have a big square where the side lengths are a plus b and a plus b on this side. And if I look at this square, I could split it up into pieces and find the area in a different way. So if I split it up like this, the area of this section would be b squared because it's a little square with side lengths of b. And this part would be a squared. And then this rectangle right here has side lengths of b and a. So I would just do a times b to find that area. And then I would also do a times b to find the area of this rectangle. And so to find the area of the entire square, I could do a squared, which is the little square, plus b squared, which is the bigger square. And then I would have AB plus AB, but since there's 2 of them, I could simplify that to just be 2AB. And that's one way that I could represent the area of this square. And if we compare these 2 squares, notice that the side lengths of the squares are the exact same. So they both are a plus b, which means that the area of these squares are equal to each other. So in this case, we found the area to be 2 times a times b plus c squared. And in this case, we found the area to be 2 times ab plus a squared plus b squared. And since these areas are equal to each other, that means that these 2 expressions are equal to each other. And if you notice, this part of the expression and this part of the expression are exactly the same. And so you could also say that this part is equal to this part, which is where we get the Pythagorean theorem from, where we say that a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse of a right triangle. So that's why the Pythagorean theorem works. And like I mentioned earlier, you can use the Pythagorean theorem whenever you want to find the missing side length of a right triangle.
Okay, so let's go through the rubric that you guys will be evaluated on for your video projects and talk about how this video meets each of the criteria in that rubric. So the first criteria is quality, which means that the visuals and audio in your video need to be clear and that it's easy to see and hear whatever you're talking about. So the best way that I've found to create a high quality video is to create a PowerPoint and then upload the PowerPoint to my iPad and record the screen of my iPad as I'm talking. So if you have a tablet, that would be my recommended method of creating videos. But you can also do it with a dock cam or even set up your phone if that's easier for you or if you don't have an iPad. But just make sure that it's really easy to see and hear whatever it is that you're talking about. The second criteria is that your video should be approximately 5 minutes long and it should never be longer than 10 minutes. So in this video, the Pythagorean theorem is a relatively complicated formula to explain. And so it took me about 8 minutes to give the example and also explain the why of the formula. So some of your videos may be longer than 5 minutes, but they shouldn't ever be longer than 10 minutes. So that's the timely piece. And then the next criteria is that your video includes a relevant example or sample problem. So in this video, the way that I included that was with my birdhouse example, where I worked through an example of how you could find the missing side length of a right triangle, and I made it relevant by using the birdhouse example. Um, and on some of the videos that you guys will be making, you won't necessarily be making it about a formula. And so you may come up with some other type of example or sample problem that's related to the topic you're explaining. But you should always have some type of example or sample problem in your video. And then the last criteria is the most important one. This is the one that is worth the most points. And that is that your video explains the why of your assigned topic. So if your topic is a formula, like in this case, you need to explain why that formula describes whatever it's supposed to describe. So in this case, when I went through and I showed how you can find the area of the two different squares, and I showed that because those two squares are equal and their areas are equal, that proves the Pythagorean theorem formula. That's how you would explain the why of the Pythagorean theorem. And so in your videos, you need to explain the why of whatever your assigned topic is. So in the case of a formula, it would be explaining why that formula is the correct way to find whatever it is you're trying to find. And if it's something else, like maybe categorizing quadrilaterals or something, I want you to explain kind of like the thought process for how we categorize quadrilaterals, and like why it would be important to be able to categorize them. So if you ever have any questions about what it would look like to explain the why of whatever your topic is, feel free to reach out and I'm happy to help explain that. But that's how this video would meet the criteria on the rubric. So if you have any questions, let me know, and I hope that this was helpful for you.